Hello. In this particular lecture, we will look at the concept of declared distances at an airport. Please watch the tutorial on declared distances. What I have done in this lecture is just an example of the numbers at Mumbai airport, but we did not do the calculations, right? To calculate the declared distances, you actually need to look at various aspects like the accelerated stop distance, takeoff distance, etc. Those have been explained in detail in the tutorial. So, after you watch this lecture on declared distances definition, I would recommend you to watch the video on the tutorial of declared distances, which will greatly improve your understanding. Let us first start with a very brief definition of takeoff. Takeoff consists of basically these three segments: the ground roll distance, the transition distance, and the climb distance. Takeoff starts when the aircraft is at rest and given the permission to proceed. The ground roll distance or the takeoff ground run, called as TOGR, is the distance on the ground from the starting of the rolling of the wheels to the place where the aircraft leaves the ground. But as you know, even when the aircraft nose wheel lifts up, the tail wheel is still rolling. In case of a tail wheel type aircraft, the main wheel is still rolling, and then once you leave the ground, there is a transition distance. During this transition, the aircraft goes into a climb or beginning of the climb, and then there is a climb, and the initial climb for the takeoff is supposed to end when you clear the obstacle height, which is considered to be a 50 feet obstacle at the end of the runway. So, the takeoff distance or TOD is the ground roll distance plus transition distance plus the climb distance, or from the point where the aircraft starts rolling to the point where the aircraft attains the obstacle height. That distance is called as the takeoff distance. Similarly, let us look at landing. Landing starts when the aircraft comes at a height called as a screen height of 50 feet. So, from that point till the point it touches the ground is called as a flare, and flare is very much a function of the piloting technique and also atmospheric conditions, center of gravity, and several other factors. Okay. It is a transition from being in the air to ground. So, when the aircraft touches the ground, the flare ends and the landing run starts till the aircraft comes to a complete halt. So, the total distance on the ground from the place where you achieve the screen height on the runway to the place where you come to an end, that whole distance is called as a landing distance. Now, there are some concepts which we need to understand regarding an airport. There is a concept called as a clearway, abbreviated as CWY or sometimes only CW. A clearway is an area that is clear of obstacles beyond the paved runway. So, this area has to be under the positive control of the airport authorities, but it need not be paved because we do not expect the aircraft to actually physically go on the clearway. Clearway is used only to clear the obstacle height. So, we expect the aircraft to have left the ground before the clearway, and clearway is generally used only to clear the obstacles. Okay? It is an unprepared piece of land, or it could also be over water, right. The purpose is to reduce the initial climb performance restrictions that could be there on the aircraft. Here is an example of a clearway. This is the clearway of runway 27R07L on Heathrow Airport. You can see that this piece of land is the clearway. So, the aircraft which will take off from here has to lift off within this pavement, but this clearway is provided for it to achieve the obstacle clearance height. As I said, it need not be always over land. You can also have a clearway over water. Here is an example of LaGuardia Airport in New York. runway 2214, the clearway is over water. So, you can see here that the runway extends up to this point and this area is the clearway. And you can also see that some avionic equipment have been mounted on water beyond the clearway to provide the guidance to the aircraft. These are probably the lights which are a part of the approach lighting system. We will study about this in a separate session. So, clearway is an area which is under the positive control of the airport, could be over land, could be over water, where the aircraft after takeoff or after liftoff tries to clear the obstacle height. Okay. So, stopway must be able to take support the load of the aircraft during landing, because it is possible that the aircraft may actually go in the stopway in case of a bad landing. So, the stopway is supposed to be on ground and also under the control of the airport authorities, and it is a pavement that can be expected to bear the weight of the aircraft, although it can get a bit damaged. We do not expect impact on the stopway, we use the stopway for stopping the aircraft during emergencies. So, this is normally indicated in the charts by large yellow converging stripes, as we have seen in this particular image. So, the displaced threshold is the portion of the runway that starts before the runway threshold. Runway threshold is the aim point or the point where the aircraft is supposed to land. But sometimes you are not allowed to use the end of the runway because you have to take care of the obstacles. Here is an example of a displaced threshold. You can see that there is a runway pavement available, but these two white arrows and that white bar indicates that the threshold is displaced. The white bars shown here, they are the threshold or the point at which the pilot aims to touch the ground, and these arrows indicate that the threshold is displaced. Now, why is it possible? Why is it required to displace the threshold? The reason is that there could be obstacles in the approach path of the aircraft beyond the runway which do not allow it to come at the approach angle. So, the displaced threshold is a pavement which is available for takeoff. That means from that side to this side, if the aircraft is taking off, it can use the threshold, but it cannot be used from this side for landing purposes, right. So, as I said, it is identified by white big arrows pointing to the actual runway threshold. Now, keeping all these in mind, we should understand that there are 4 declared distances at every airport. Every airport declares these 4 distances and they are mentioned on the charts. Sometimes these distances are reduced because of operational considerations. So, then these are indicated via the NOTAMs. So, what are these? The first is called as the TORA. TORA stands for the takeoff run available. The next one is TODA. TODA stands for the takeoff distance available. Remember, run is when you leave the ground, distance is when you leave the ground and clear the obstacle. Then you have ASDA or the accelerate stop distance available, and you also have LDA, which is the ALDA, which is the landing distance available. Okay. So, now let us look at all of these one by one. How are they defined? TORA is defined as the runway length which is approved for ground run of the aircraft at takeoff. So, during the takeoff, the TORA is the pavement which is required to take the loads of the aircraft as it rolls and as it lifts off. Then you have TODA, which is the length of the runway available plus the length of any clearway that may be available beyond the runway to allow obstacle clearance. If the runway length is large enough, you might obtain obstacle clearance over the runway itself, but it is not necessary. In some airports where there are land limitations, you may allow the clearway to take care of the obstacle clearance, as I showed you in the previous slides. Then you have the LDA, which is the landing distance available. That could be the runway length approved for a ground run of an aircraft at landing. Just like TORA is approved for takeoff, LDA or LDA is approved for landing. And finally, we have the ASDA, which is the length of the takeoff runway available or runway available during takeoff plus the length of the stopway. Stopway is required to allow the aircraft to go to that place in case of a rejected takeoff. Okay. So, we will now look at all these things in more detail. The question that arises is, why does the airport require to declare the distances, mention them in the charts, and also keep updating them? The reason for that is that the runway pavement that is available at the airport, the entire pavement may not be available for takeoff or landing, either because of fixed constraints or because of certain constraints like some equipment not working or some taxiway being blocked. Okay. So, the thing is that if an airport has a displaced or if a runway has a displaced threshold, such as the one shown in this particular figure, that reduces the landing distance available, but you can notice that the takeoff distance, takeoff run and ASDA, they are not affected. So, from this side when you are approaching, from right to left when you approach, okay, or even from left to right, the takeoff run available, the takeoff distance available and the ASDA is not reduced because of a displaced threshold, because that runway portion is available. But if you are landing from the left to right, then you cannot use the displaced threshold length, and therefore presence of a displaced threshold reduces the landing distance available, but there may not be a displaced threshold at the runway. As I said, threshold is displaced only to take care of obstacle clearance in the approach path of the aircraft, and you may not have obstacles. So, therefore, you don't have to displace the threshold. In fact, a displaced threshold basically means that certain resources of the runway which could be used for landing cannot be used. Okay? So, it is like a small loss actually. Then the stopway that is at the end of the runway, it cannot be used during takeoff or landing, because stopway is only meant for landing and aborting the landing. So, it is so called accelerated stop distance. So, you are not expected to actually be in the stopway during takeoff. So, therefore, the takeoff run available, takeoff distance available, they and the LDA, landing distance available, they will be without the stopway, but the stopway is going to add to the takeoff run or distance available in case it is present for the accelerated stop distance, because you can go in the stopway only in emergency, only when you reject the takeoff. Similarly, stopways could be present on one end, both the ends, or they may not be there. Okay. In this example, we are seeing stopway and clearway only at one end. Okay. Also, the displaced threshold may be present also again at only one end of the airport, as shown in this particular case. So, because of all these reasons, although there is a runway pavement available, there may or may not be stopway and their clearways available. People who are operating the airport, they need to inform the pilots who are operating aircraft to take off and land what distances are available, so that they can plan. Okay. So, that is why every airport needs to declare the distances. Also, as I mentioned, sometimes the distance may actually be there but not usable because of certain operating limitations, which is notified using NOTAMs. Let us see how the declared distances are shown on the aircraft charts. Here is an example of an airport diagram, and if you look at the label and if you zoom on that label, you will find there is a D with a black background, white colored D with a black background. This mark indicates that the distances which are indicated in the chart are declared distances. Okay. So, you can see this is how it is shown. You have runway declared distance information. So, runway 1, runway 19, TORA, TODA, ASDA, ELDA. Similarly, TORA, TODA, ASDA, ELDA. Notice the numbers are not the same. Runway 1 has TORA of 6100, but it is only 6350. These are in feet, and they could also be same, but they need not be the same. Okay. As an example, let us look at Mumbai Airport, which is abbreviated as VABB under ICAO. In IATA, we call it as BOM. When you book a flight ticket, you don't enter VABB, you enter BOM, and that is how you can get your tickets. But the name of the airport is Chhatrapati Shivaji Maharaj International Airport, or CSMIA. So, this airport, here is the aerodrome chart of VABB, which has been taken from the AIP, Aeronautical Information Publication. So, AIP India publishes details about all the airports, and this is, by the way, the most authentic and reliable source of information for any airport. So in AD2 VABB 1-1 published on 19 July 2018, here is the airport diagram or airport chart of Mumbai airport. As you can see, Mumbai airport has 2 cross runways. Okay. So here is the aerial photograph of the Chhatrapati Shivaji Maharaj International Airport or VABB with the 2 runways, and to set the context right, here is the north direction. So therefore, at Mumbai airport we have one main runway which is 0927, 0927 because you can notice 09 means it is aligned at 90 degrees from the north and 27 means it is aligned at 270 degrees from the north. The runway numbering has already been explained in one of the presentations, but I will clarify to you once again. You look at the runway number from the landing direction, at what angle from the north rotating clockwise you require to move to come at that angle. So for runway 09 you need to move 90 degrees from north when you are coming to land. So the number is 09. This is the main runway which is 3448 meters long and 60 meters wide, and that is, by the way, the pavement, that is the structural pavement or the runway available. Similarly, you also have a secondary runway which is 3214. In 3214 is a thinner runway. I mean, the width is only 45 meters and the length also is small, it is 2871 meters. Notice that this portion is available, but it is actually a flexible pavement, not the rigid pavement. So the pavement is only from this point to this point, which is 2871 meters, but there is a small, there is a large length available here. We will talk about this in the later stages. Also note that at this end as well as at this end you have certain space here. This is the runway edge safety area. This is still inside the airport. Okay, it is still inside the airport. It is meant for the safety of the operations. Now, let us look at the factors that affect the declared distances. First thing is that the physical runway length which is available, that is the baseline for TORA and ASDA, and if there are no displaced thresholds, if there is no stopway, if there is no clearway, then TORA, TODA, ASDA, LDA are all the same, equal to the runway length. The presence of stopways, clearway and displaced thresholds are going to make changes to these values. For example, as I already mentioned, if any runway end has a displaced threshold, it only reduces the landing distance available from that direction. Similarly, if a stopway is absent, then ASDA equal to TORA. As shown in this example, there is no stopway, there is only a displaced threshold, that also only in one side. So if the stopway is absent on both the ends, then ASDA is equal to TORA. And if the clearway is also absent, as in this example, then the TODA is also equal to TORA. Okay, that is the case in Mumbai airport. There is no stopway, there is no clearway. Okay, but the threshold is displaced at all the ends of the runway. Now you have runway end safety area, and there are certain obstacles, surfaces. We have already talked about it in the airport design section. All the obstacle surfaces around the airport and their angles, they have been marked. So if there is any obstacle which is present in the clearway, then it reduces the TODA. If there is an obstacle present in the stopway, then it reduces the ASDA, because that much portion cannot be used. Okay. So that is how the obstacles and the runway edge safety areas sometimes affect the values of TODA and ASDA, and we will see one example also of this. So let us look at the steps when we want to calculate the declared distances. What steps do we follow? Okay. So first is use the physical runway length called as the RL, and that decides the TORA. So TORA is equal to the physical runway length available. Then you check whether there are any thresholds displaced at runway ends. If there are, then reduce the LDA from the TORA by the amount of displaced threshold. After that, you should check for stopway and clearway availability. If stopway is present, it will reduce the ASDA. If clearway is available, it will reduce the TODA. And then you apply the obstacle and OLS clearances, and these, if present, they will reduce the TODA and ASDA further. So let us do it step by step. So first, step 1 is using physical runway length, and we will run the example of Mumbai airport for you. So the physical length decides TORA. So, runway 1432 has a runway length, physical length of 2871 meters, and runway 09, it has a length of 3188, and 27 has a length of 3488. As I mentioned, on both the sides you do not have the runway length of the same direction, correct. So, therefore, in the table of TORA, TODA, ASDA, ALDA, we can simply enter the values of TORA, takeoff run available for all the 4 runways or both the edges of the 2 runways using the value of the TORA, which is the pavement length available in that particular direction. Okay. So, this is very straightforward. Now, first thing you do is check the displaced thresholds. Remember, this only affects the landing distance available. Now, at runway 14 in Mumbai airport, there is a displaced threshold of 400 meters. So, the LDA will be 2871 minus 400, that is 2471. At runway 32, the displaced threshold is 198 meters. Therefore, the LDA will be again 2871, which is the runway length for 1432 minus 198 meters, that is 2673 meters. At runway 09, the threshold is displayed by only 70 meters. So, the LDA will be the landing distance available, which is 3188 minus 140, that is 3048. And at runway 27, the threshold is 483 meters displaced. So, the LDA will be the runway length available, which is 3448 minus 483 meters. So, with this information, you can straight away enter the data in the LDA column based on the TORA and the displaced threshold. Okay. So, now we have got the table full of the TORA and the LDA information. Now, we go to step 3. So, the first step will be check the availability of the stopway. At Mumbai airport, there is no stopway at any end. So, therefore, ASDA equal to TORA, right. So, we can just enter the values of TORA in the ASDA column at Mumbai airport. Also, we check for clearway. Now, at Mumbai airport, there is no clearway at any end. So, it is very simple. Therefore, TODA will be equal to TORA. So, therefore, the TODA values that you will see can be entered from the TORA values directly. So, with this we have now filled up. Now, we apply obstacle and OLS constraints. These obstacles and constraints, as I mentioned, they reduce ASDA if they are in the stopway, and they reduce TODA if they are in the clearway, but we do not have them in Mumbai airport. So, therefore, the final distance is as shown below. So, this is the final table for the declared distances of Mumbai airport. Now, if you actually operate at the Mumbai airport at any point of time, you might find that the current values of these parameters may be a bit lower because of certain constraints that are there because of operational limitations. These are notified by AAI through the NOTAMs. But if all is well, normal conditions, not during monsoon, not during any runway construction activity, these are the distances available. Now, there is just to brush up, what we do is we first look at the physical length and fill the TORA table. After that, we apply displaced thresholds if any at runway ends, get the LDA. After that, we check the software availability of the stopway, and if there is, we adjust the ASDA or minus the value to get ASDA. Then we look at the clearway. If it is available, then TODA will be reduced. If not, and then finally we look at any reduction in ASDA or TODA because of obstacle and OLS clearances in the stopway and the clearway respectively. So, these are the standard steps of arriving at the distances. But there is also an interesting concept of negative stopway. Okay. Let us have a look at it by an example. Now, FAA specifies that there should be 1,000 feet of runway safety area beyond the last bit of a usable pavement at any airport, right. Now, this 1,000 feet can be relaxed if you put the EMAS system, engineered material system, but that is very expensive. And we have already seen what is EMAS in the previous lecture when we talked about the airport design. So, if you have EMAS, you do not have to have 1,000 feet of runway safety area beyond the runway, beyond the pavement, but if you do not, because it is expensive, you need to have 1,000 feet clear. Now, suppose it is not possible to have 1,000 feet clear because you are in the middle of the city or you are at a location where you do not have land available, then FAA gives you two options. One option is you physically reduce the runway length until adequate runway safety area is present. This is done by reducing the value, by not using some part of the runway, or you can reduce the declared ASDA and or LDA, right. So, let us see how it is done. So, here is an example of an airport called as the Naples Airport. This is not in Italy, this is in Florida. Naples Airport in Florida, and the name of the FAA designation is KAPF. Now, if you look at in the map, you will find this is where it is located in Naples in Florida, and if you zoom further, you will find that this airport is surrounded on all sides by roads and by residents. So, therefore, it has got two runways, as you can see. So, here is a section of the airport map. So, we can see that this has got two runways, runway 1432 and runway 0523, right. So, runway 0523 has a length of 1850 by 100, okay. These are in feet, and runway 1432 has a runway length of 5000 feet by 100 feet width, okay. Now, you can notice this area is residential area, there are roads around the airport on all the sides, it is occupied. So, runway 14 at KAPF, which is this one, this runway, right, this runway. The runway length available is 5000 feet, that means the constructed length of the runway is 5000 feet and 100 feet wide, as we can see in the image. However, there is a road which is located 450 feet beyond the runway end, right. Now, we need 1000 feet there, but you have only 450 feet. So, therefore, what has been done is that the ASDA has been reduced to 4550 feet to accommodate the 450 feet plus the 550 feet required, okay. So, ASDA has been reduced. You can see here TORA is 5000, but ASDA is 4550 to accommodate this. So, this will ensure that the runway safety area is 1000 feet. You will not use the last so much portion of the runway, even though it is available. Now, there is no stopway here, there is no clearway here. So, therefore, actually ASDA should be equal to TODA, but that is not the case. ASDA has been reduced to 4550 in this direction to accommodate this particular constraint. And by the way, there is also a displace threshold, okay. So, because of that, ASDA is further reduced to 4420, right. It is further reduced because of the displace threshold. So, this is an example of a negative stopway to accommodate the 1000 feet RESA requirement. Let us move closer to home at the capital, Delhi Airport. Delhi Airport, previously it used to have 3 runways, but very recently on 13th of July 2023, one additional runway called as 11L and 29R, the one that you see here in between. This runway was earlier not there. This has been commissioned couple of years ago, okay. So, this is a new development, but if we look at the data available for the TODA declared distances, you can see that for runway 1028, which is this runway 1028. So, here we see that there is no displace threshold at both the ends, the entire pavement is being used, and therefore, you will find that all the distances are the same. So, you have a length of 3813 meters available, that is equal to TORA, TODA, ASDA and ELDA. There is no stopway, there is no clearway, there is no displace threshold. So, this is one standard case where you have no correction or no changes in the declared distances. TORA, TODA, ASDA, ELDA are same. But if you look at runway 11R and 29L, the one which was earlier available, this runway, here you see that in this runway you can see there is a displace threshold here. This is about 645 meters, okay, and here you have a much larger displace threshold. That value is 1460 meters. So, because of that, even though you have length of 4110, you reduce it to 3465 because of the threshold, and although you have 4430 length available, you have to reduce it to 1460 by 1460 to 2970. Okay. So, that is the effect of displaced threshold. As I mentioned, it only affects the LDA. And then you have the last one, which is the 0927, the small runway that you have. This was always there, mainly used by the military mainly. Okay. In this you can see that there is no displaced threshold at this point. So, therefore, there is no reduction, but here there is a small displaced threshold, and therefore, the value of the LDA has been reduced from 2816 to 2665. But since runway 09 does not have any displaced threshold, the runway length is 2816. So, that is the TORA, TODA, ALDA and ESDA. But in case of 27, that is from this direction, because of the displaced threshold, you have to reduce by 151 meter the landing distance available. Thank you so much for your attention.